So in this question, you can crack this question if you know only one basic physics logic. What is that basic physics logic? See, there is something called power, right? Everyone know this. So there are three popular formulas to calculate powers. One formula we know that work done by time, if you will do, you can calculate the power. Okay. Now this work done by time, you can also write like this work done, you can write force into displacement and by time. So displacement by time is velocity. So force into velocity is another formula, and torque into angular, capital T representing torque here, into omega is your another formula. So mostly students remember this formula, but these two formulas they miss from their mind. So next time as engineer, whenever power word comes into your mind, these three formulas should be on your fingertips, in your brain. Whenever someone is saying power, okay, then W by T, F into V, T torque into omega, right? Not only engineers, wherever the power word is coming into picture, like suppose just fun, if someone is saying that this politician is very powerful, or this person in India is very powerful, it means what? W by T, F into V, and torque into omega. So omega means what? Angular velocity. V means what? Linear velocity. See, F into V we use when we have linear motion. Torque into omega we use when we have rotational motion to calculate the power. Okay. So right now we are doing torsion. So in torsion, your shaft will not go like this. Your shaft will go like this. So torsion is there. That's why T into omega we should use very frequently. So in this question, what you have to do, you can see what they are asking. The ratio of power which can be transmitted by shaft A to that shaft B, if maximum shear stress remains same. I told you, right? Whenever you will discuss concept of torsion or numericals in the torsion, any one thing will be constant. Sometimes they will give in the question itself what is constant or remaining same, or sometimes by your basic IQ you have to judge, like in previous question your theta 1 and theta 2 was constant, right? So when we'll solve all the questions, there are so many questions where your T1 and T2 will be same, right? Already these things we have discussed in the theory part. So two shafts A and B are made of same material. Now you see why they have written same material here. If they are writing same material, which property will be same, guys? Tell me. Radius will be same, or J will be same, or G or T, or what will be same, or theta, what will be same? Tick on my screen. Which property will be same if material is same? So guys, if material is same, they are saying material is same, then your G value will be same. Okay, very good. Then your G value will be same. And if they are saying radius is same, then of course your polar momentum potential will be same. Correct. This T and theta is not the shaft property. They are because of the applied torque. Okay. So and the tau also, it is not the material property, it is again based on the torque. Okay. So that's why they are mentioning here maximum shear stresses remain same. Now whenever maximum shear stress is coming into picture, so you should know where is maximum shear stress acting. So you see, just one basic logic you understand. Suppose you have any shaft here. So on the shaft, when you will apply the torque, you know at radius r, or when you will revise, if you have revised the chapter, then you should know that your shear stress variation is there. Correct. So that shear stress variation, so at the center you will not be having, you will be having some other shear stress. At the here you will be having some other shear stress. So the shear stress is varying means shear stress is not constant here. How will you know that how much shear stress we are getting, and how to bother about the variation of shear stress? So for all those things you revise, because it is a detailed lecture I have given. Now you see one thing. Your T by J is equal to tau by R is equal to G theta by L. Which two portions you have to use for the calculation purpose? It depends on the question framed. Like in last question was based on these two. Okay. So in that way we have to think, like present question will be based on which two. So of course, because they are talking about the shear stress and torque is also given, so we'll be using, you want to use these two. No, you should use these two. I will tell you why you should use these two. Because see, concept is about the power. Power is related to torque into angular velocity omega. Omega is not coming in your torsion equation. Okay, it is separate concept. So we should connect torque. At the same time, diameter of the shaft is coming, correct, and shear stress concept is coming. So these two are only given in the first two, like T by J is equal to tau by R. So only these two you collect and solve. So you see, first you go for the torque. How much torque? So it is very, very easy. I will change the color. You see how it is easy. Your T is equal to tau by R and J is here, right? So that J I am sending here. Just after that you can crack the question. So from here, J value you substitute here, it will, R will get cancelled. R also you put in terms of diameter D by 2. J also you put what is J value? Pi by 32 D power 4. So 1D will get cancelled, and you can clearly see here your torque is proportional to your D power cube. Now torque is proportional to your D power cube and your power is proportional to torque, right? So it means power is proportional to D power cube. Okay, so you can say that you have two different shafts. One shaft is here and one shaft is here, and they are same material, so G value is constant, but diameter is not same. Diameter of the shaft B is twice. So if A has diameter, for example 10, then B will be having diameter 2 times of 10. Diameter of shaft B is twice of shaft A. Okay, so diameter is twice. So you can clearly see that power for the shaft A will be proportional to its own diameter power cube, but power for shaft B will be proportional to the 2 times of diameter power cube, right? So now if you take the ratio of the power, but again you should not do mistake. They are asking PA by PB or they are asking PB by PA. Here students may do mistake. They are asking what? Shaft A to shaft B. It means PA by PB. So you divide here. So which answer will come, guys? Out of these 4 options, which option is correct? Yes, 1 by 8 will be correct option. Okay, very good. So these are, see, very easy, and torsion is, that's why very, very easy. When I was teaching bending, that time you guys were like saying that it is somewhat heavy. Actually, because you did not revise the video lecture, that's why it was heavy.